Hi everybody, this is my lead acid alum conversion I want to talk about a little bit. So this is my fourth charge and discharge. I did already 3 before, so it's almost ending up. I have a 12 ampere hour motorcycle battery that I bought new at the auto part, and I never put the lead acid, which is here completely new. I have to bring it back. So I never put the acid, and I put the alum. I put the McCormick alum because I was not waiting for my order coming. And it's a little expensive because in 1 liter, 1 quart of distilled water, I have to put like 3, 6, 9 of 1 ounce and 9.9. So, but since then it's working some good. So now I want to show you the graph. One moment here. Okay. This software of the circle specialist is not so handy, but I have to run it with the mouse because I cannot show all the 3 or 4 hours that I'm doing now in one go. So this was the charging. I don't know if you can see. I charged it with the power supply this time, after I explained how I charged it before. So this was a 15.5 volt. You can see the straight line for more or less 1 hour, 1 hour and 10 minutes. I charged it. It went from 3 or 4 ampere down to 100 milliampere. After I disconnect the charger, and this is the recuperation, it went down and it set it down in a nice wave, resting until 12 volt here. Let's see if you can make it a little bigger. Okay. So here we open a little bit. Okay. So here I disconnect the 16 volt, the power supply. It went down to resting, and here I connect the load. The load is a 0 goal light. Let's see if you can show it. The one then John have also, and they are very nice lights. So it's a 3 watts, 250 milliampere at 12 volt, still lit. Not so much because now we are 8.8 volt and only 35 milliampere left after almost 3 hours and a half or 4 hours almost. So this is the discharge, and let me see if I change. Okay, so it went from 12 volt, dropped down immediately to 10.97, and it slowly went down. Here I connect something else to try. So you see all the steady discharge. 10 volt, he reached 10 volt here, went down to 9, 9 930 920, and this is a very linear discharge. Let's see where we are now. Okay, I have to run with the mouse. I cannot change the scale. Okay, here I connect something else. I disconnect the lead. So now we are here. Let's make a little bigger this. Now is 8 volt, 887, going down in this increment. Let's see if we can focus it. Okay, and this is how discharge so we are 887, 888, 887, and counting. And it is very nice. What I want to say, I start to discharge the battery at 2 o'clock, 2:10, yeah, exactly. Was 1097 volt at 265 milliampere, and now is 5:50, almost 6 o'clock, so it's almost 4 hours after, and I'm down at 887, 887. The light still glowing. Of course it's not so powerful like before, but still light. And we are down at 30, a little bit more than 30 milliampere. Voila. So I charged this time with the Master power supply, 15.5 volt, for an hour and a half, and it was absorbing like almost 3 ampere at the beginning, and went down after 1 hour and a half to 100 milliampere. And the first time then I convert this battery, I charge it the first time with my 6 coiler here for almost 2 hours, and was gassing the battery. Was very nice. It keep the charge at 15 and a half, 15.6. I charged it. I discharged it the first time, and was a little bit better for the current, because I didn't use the gold zero. I use a 20 ohm resistor, and so I start like you see at 12 o'clock at 550, 600 milliampere with a 20 ohm resistance, and I went down until 4 volt and was still 250 milliampere after 3 hours. So was more ampere than was more power in. So the other, this is the second, and this is the third. The second Oops, something is interrupting the video, but anyway, the second time I charged it with the spanker here, the second and the third time, and because I don't have a solar tracker, I have only this regular solar charger. So my question is, let's see which power supply better I can use. I think the 6 coil, I'm gonna try again with the 6 coiler to charge it again. I think it's a better charge, but also the power supply was nice. So I hope I can put the two videos together. If not, I'm gonna make two videos because I see something interrupted here. So thank you to John Bedini and to all the people in the forum. They are really an inspiration, and so thank you again for watching. And here still going. Another thing that I want to show is of course, if I put the oscillator, you know, then I build with the diode. So let's put it on. Stay there. So if we put it on, you see is enough power, because they go around 30-40 milliampere. So it's a nice light. So it's definitely working. And of course here we see that we discharge it. And is recuperating. Okay, so thank you very much for watching, and let's continue the experiment. I think I'm gonna maybe add some alum, if you can, to the battery. The new alum then is coming. Okay, thank you for watching. Have a nice day. Bye bye. Thank you. So I'm back. I want to do a little experiment. I mean, not a little experiment, but to see how recuperate if you will disconnect the load. So here we have the light. Sorry. And let's turn it off for a moment and see how you see those are little increment of 10 millivolt up and down. Is set it down the battery 884, 885, and so now let's go down here. Let's turn off the light and see how find is level. Okay, so it's raising up little by little. And not so much. And after we can connect I want to try to connect again not the light but the 20 ohm resistance, which is what is supposed to be a 20 hour rate for this battery. No, it's more and less. It's 600 ampere hour C20 for a 12 ampere hour battery, but of course now is empty. Almost was 32 milliampere with the load. So it's slowly finding its level up. And see if you connect the 20 how much he give me. Okay, still going up a little bit. It probably go up more if you leave it, but let's connect the 20 ampere, the 20 ohm resistance now. And let's see where it's going down. So it's going down to 844, going down, and we have now a little bit more current. We have 39 in the scale of 50 milliampere. I mean 500 milliampere. We have 380 milliampere. So it's pretty good. After 4 hours, and so, and this is the load here. I disconnect the light and I connect the 20 ohm resistor, 836, and the scale of 500 milliampere. Here, I don't know if you can read it. This is 50, 500 and 5 ampere. So 500 milliampere is the scale, and we have 380 milliampere. So maybe I was wrong, it's the same. Also the power supply, charge good, but I want to make some other experiment with the solar tracker that is coming. But you see, it's steady, 833. I think its plateau is nice around 9.8 volt for this battery for this moment. How I converted, so it's very nice. I like it. You can see then it's tracking. Let's see if we can open up a little bit. So this is the curve when I connect here I disconnect the light. I let them reset a little moment, couple of minutes, and I connect the 20 ohm resistor, and so from 885 it dropped down and it start to find its way. You see. So this is the curve. Those are millivolt. and it's keeping there, going down of course slowly, but now this is the C20 discharge rate. 8 volt, because now we have 828, but still the current is steady, 380 milliampere. Very nice. And this is the 20 ohm resistance. This is my old crystal battery. After years, then I made it. I just put a little bit of water and going strong. So I have to decide if the power supply is a better charge, or the spanker, or the 6 coil, and see. But it's pretty nice. And meter don't lie, like they say. So here you see when I connect the resistors of 20 ohm resistance, and you see the discharge curve going on, and it's there. Let's see, I wanna leave it on until I have something in, to see where I end up. So with the resistive, now it's also warm, so still current inside. With a resistive load, like they say, with a resistance, I have 380 milliampere. So let's disconnect one moment. Let's see. Okay, let's disconnect the resistance. So let's disconnect the resistance, and I reconnect the light, the zero light. Now you see the news recuperating. Let's recuperate a little bit. Just to see, and now I turn the lights on. Not working because I didn't connect it right here. Of course, now it doesn't light anymore. Let me change it here. The same. So it takes a while because we don't have so much energy anymore inside. And now let's open here. So this is when I recuperate a little bit, and now, so we still have some light here, and now also we have more. Before we had 30 milliampere, now we have less. Now we have 22 milliampere, and with 22 milliampere still the light on, and this is how it's behaving. So I think it's super good. So with this 3 watts light is consuming 22 milliampere, 8.7 volt, but we have more inside because now let's disconnect. Let's put the 500 milliampere.